So, what's the observable universe all about? Basically, it's the part of the cosmos we can actually see and check out with our telescopes and stuff. But there's a catch. Light, which is how we get info about space, can only go so fast. That means we can only see stuff that's not too far away. We can't just look at stuff that happened way, way back. The observable universe is huge, like 93 billion light-years across. That's way bigger than the universe's age, which is around 13.8 billion years. Why the difference? The universe is expanding? Stuff that used to be close is now far apart, and it takes light longer to reach us from those spots. Yeah, it's a massive, crazy place, the observable universe. We still have tons to figure out, but with things like the James Webb Space Telescope, we're learning more all the time about what's out there. If you want to hear about structures caught on camera by the Space Telescope, stick around if you want news related to space. Hit that like button and subscribe to stay in the loop. Now, what's beyond all that? We can see. To get super far away, we'd need some wild tech, like warp drives or wormholes, to bend space and time. Scientists argue about if that's even doable. Some say it's impossible or messes with the idea that nothing can go faster than light. Even if it could work, we'd need tech way beyond what we have now, or even our understanding. There's a theory that the whole universe is way bigger. It's like 10 to the power of 23 times bigger than what we can see. That's a number so big it's hard to wrap your head around. Since we can't see or measure that part, we just don't know what's out there. But we can still come up with ideas based on what we do see from faraway galaxies. That's where NASA comes in. NASA, with help from other groups, has taught us a lot about the universe even before the James Webb Telescope. They already had those ultra-deep field images from Hubble. But when the James Webb Telescope arrived, scientists used it to spot the most far-off galaxy ever. The images showed tons of galaxies shining way back when the universe was just starting, like millions of years after the Big Bang, about 13.8 billion years ago. Because space is expanding, light stretches out and turns redder, the James Webb. The telescope can spot that infrared light, so it can see galaxies forming back in the early days of the universe. It's looked at a bunch of these distant galaxy fields, helping scientists learn how fast stars used to form. There were a lot of galaxies making stars way back then. It's mind-blowing stuff. People have wondered for ages if we're alone in the universe. These new finds make it seem like there have to be tons of galaxies we can't see. Makes you wonder, right? Could there be aliens out there? The chances of life beyond Earth seem higher than ever. There are tons of planets outside our solar system, exoplanets, that we've found. Some might be like Earth and could have life. The James Webb Telescope even found water on one of those planets, WASP 96b. It even saw signs of haze and clouds, which we didn't expect on a possibly habitable planet. With all the possibly livable places we find, it's hard to say for sure aliens don't exist. We don't have proof yet, but there's a lot suggesting it's possible. What about the multiverse? The multiverse, or many worlds, is this idea that there are tons of universes besides our own. It comes from quantum physics, which is about how super tiny stuff acts. Some say that when we look at something in quantum physics, it splits into different versions, each with a different result. It's just a theory and we don't have proof. Some scientists like it, some don't. Since we don't know what's outside our universe, the chance of a multiverse is as good as any other guess. It's a cool thing to think about, but we need more evidence. Is there such a thing as dark flow? That's a tricky question. Back in 2008, some people thought they saw galaxy clusters moving faster than they should. Based on what's in the universe, they called it dark flow and said it might be some dark matter or energy pulling them. But it's not a sure thing. Studies say it's real and could be a big structure pulling on those clusters. Others say it's just errors in the data. We can't say for sure it's out there. We need more research to know if it's real. What do you think? Let us know in the comments. And if you liked this, hit that like button and subscribe. One of the biggest head scratchers in space is dark matter and dark energy. They make up about 95% of the universe, with dark matter being about 27% and dark energy the other 68%. Even though they have this massive on the cosmos, we haven't been able to directly find these mysterious things. The future of understanding the universe is looking up. Every new thing we find opens up even more questions. It's all a gigantic, complicated puzzle, and trying to solve it will probably keep scientists busy for generations to come. Whether it's figuring out dark matter, finding aliens, or bending space and time, the drive to understand the cosmos is a big part of what makes us human. Will we ever get beyond the observable universe? It's a cool question. Right now it sounds like science fiction, but who knows what the future holds. Even getting to the nearest star would take thousands of years with our fastest rockets. It's getting out of our galaxy, much less the observable universe, would take some serious breakthroughs in how we travel, make power, and how we think about physics. One idea is warp drives, where you bend space to go faster than light. It's based on Einstein's theories, but it would take a crazy amount of power, and we don't know the physical things involved. Another idea is wormholes, like shortcuts through space. General relativity says they might be possible, but keeping them open long enough to travel through is still just an idea. Someday. Maybe through these wild concepts or something we haven't even thought of yet. Our kids will get beyond what we can see now. What's the deal with AI in space? AI is becoming super important for understanding space. Why I can look at tons of data from telescopes, help spacecraft navigate, and even find exoplanets by spotting tiny changes in light. NASA's Kepler and TESS missions have used AI to find possible planets. AI is also used to model galaxies, simulate dark matter, and even predict space events. As we get better telescopes, we'll have way more data than we can handle without AI. The future AI could help spacecraft explore on their own, making decisions without waiting for commands from Earth. To get to the edge of what we can see, we'd need some crazy tech to get around the limits of space and time. Think warp drives or wormholes. Some scientists aren't sure if that's even possible since it breaks the speed of light rule. Even if it could work, we'd need tech way beyond what we have now. There's a theory called cosmic inflation that says the whole universe could be way bigger than what we can see. Maybe 10 to the power of 23 times bigger? That's mind-blowing, and we can't even measure or see that part. So we don't know for sure what's there. But that doesn't stop us from making guesses based on what we do know from distant galaxies. NASA with other space groups is helping a lot to know the universe well. Before the James Webb Space Telescope, we got pics from the Hubble Space Telescope. This year, they took the James Webb Space Telescope out to see the farthest galaxy. Everett's pictures showed many galaxies shining from when the cosmos was forming millions of years after the Big Bang. Since the universe gets bigger, light stretches. The James Webb Space Telescope sees infrared light, which lets us see galaxies forming way back when. Because the James Webb Space Telescope looked at a number of distant patches. We know stars formed in the early universe. Humans have wondered this for ages. Are we alone? These finds make us think there must be millions of galaxies beyond what we can see. Is there life out there? The chances of life are high. We found planets like Earth outside our solar system, exoplanets. Some might work for life there. Maybe water vapor and clouds on planet WASP 96b, a discovery from the James Webb Space Telescope. Because of the habitable environments elsewhere in the exoplanet search, it's hard to say alien beings don't exist beyond us. Even without proof that alien beings exist, we can theorize alien life exists. What is the multiverse? The multiverse is the idea that there are other universes besides ours. It comes from quantum physics as some interpretations of quantum physics say that observation can cause a quantum system to collapse into a single state. However, in another interpretation, the quantum system may break into multiple states, each having a different outcome. Now, this is all just a theory. Some scientists dig it, some not so much. It's as wild as Schrodinger's cat experiment or darkness, or the nature of Schrodinger's cat. Is there something called dark flow? Dark flow came up in 2008. It's a possible reason for why some galaxy groups move faster than they should. Based on how stuff is spread out in the universe, suggests some dark stuff is pulling them. Some say it's real, and it's a huge thing pulling on galaxies. Others haven't found it, and think the motion is because of something else. So we can't say if it's real or not. What do you believe? Let us know. Remember, like and subscribe. One of space's big mysteries is dark matter and dark energy. It makes up 95% of the universe. You haven't found them yet. The future is bright, full of discoveries. The universe is a testament to what science can do. Searching for alien life and understanding space-time may continue to shape humanity. Will we ever go beyond what we can see? Even though it seems impossible, the idea of traveling past the observable universe shows the human desire to learn. To the nearest star, Alpha Centauri, would take thousands of years with our fastest ships. Getting totally away from our galaxy would need some breakthroughs in how we make energy in physics. A solution is warp drives. Warp drives may allow us to compress space, like in Einstein's theory. However, the amount of power this needs and the unknown physics may prove a challenge. Wormholes, shortcuts in space-time, could also connect points in the universe of different universes. Though general relativity allows for this, it is difficult to maintain stability needed for space travel, whether it's through new physics or new processes. Maybe our relatives and descendants will be able to reach beyond our cosmic horizon. How? Does artificial intelligence play a role in space exploration? AI is becoming essential for understanding the universe. AI can analyze datasets from telescopes and assists in navigation for missions. NASA's telescopes benefit from algorithms that detect planets. AI is used to model galaxy formation, simulate dark matter, and even predict cosmic events. As technology advances, it may be impossible to process data without AI. Could help autonomous spacecraft explore remote regions, and analyze information in real time.